Good morning, Year 10. It's Sunday night again. It's about 2:30 in the morning, and I'm just preparing some work on scatter graphs for you. So, hope you're all listening, hope you're all sitting there comfortably. I imagine you're going to be pretty good at this. Matthew, hope you're focused. Raheem, listening please. David, stop talking to Adam. Right, all focused, let's go. Scatter graphs. Right, well, what do they look like? I think you can all remember scatter graphs, where you've got a bit of a graph and you plot one set of values along the bottom and one set of values up the vertical axes, and you've got points and you plot them, and they can kind of scatter all over the page, all over the graph. So you could have one that looks like that, or I could have one that looks quite a real scatter, a bit like that, or I could end up with a graph which might look like this. So there's kind of a pattern on the first one. It's sort of going up, and I've got absolutely no pattern there. And then the third one here, it's kind of a pattern going down. So that's what a scatter graph is. So let's think, what could it mean? What could they be about? Well, have a think. What two things are linked such that as one increases, the other increases? And a common one is, well, let's plot ice cream sales. They're going to increase as the temperature increases. That kind of makes sense, doesn't it? If it gets hotter, you're going to sell more ice creams. What about as one thing increases, the other item decreases? I'll leave that one up to you to think about that. What two value? What's something which, when one thing increases, the other decreases? I don't know. Could it be sales of wellies and temperature? I don't know. That's up for you. Now, this line that I've drawn on the graph, what's that called? Yes, Shanaz, I can hear you saying it. It's called a line of best fit. It's a line that kind of describes the relationship between the two variables. It's kind of showing the direction of what's happening, both things increasing. Now, if you are really good, what tends to happen is you could be asked to plot the line of best fit, and you just draw it by eye. Well, that's not a very good colour, is it? So you could be asked to draw it by eye. So you just have a look. Or they could ask you to draw it through what's called the mean point. So what is the mean point? Let's just write that again. What is the mean point? Well, the mean point is where you work out the mean, the average of values along one axis, and the average of values on the other axis. And you plot that point on your graph, and the line of best fit should go through it. That's what it comes. So we'll look at that in a moment. Okay, that's... oh no, I've forgotten one thing. Where one thing increases and the other thing increases, there's a special word for that. Yep, it's called positive. We say the variables have a positive correlation. And as one goes down as the other goes up, yep, that's a negative correlation. And over here, well, it's a bit random, isn't it? So there's no correlation. All sounding familiar? Great. Right, a couple of little tips before you unleash on problems. But here we go. Very careful with scatter graph questions. Look at the scale. Choose your scale carefully. So on this graph here, as you can see, the bottom axis goes up to 140, 150, and there are 10 little squares in between. So that's easy. One little square equals 1. But up the vertical axis, look, we've got 10 little squares cover a distance of 5. So let's think what's happening. Well, if I go up in twos, I've got 51, 52, 53, 54, 55. So just bear that in mind. Every two little squares is equal to 1 unit. So every two little squares equals 1. So just be careful when using the scales on these questions. this is the exercise you're going to do, exercise 5.4. You're given some data, you've got to draw your axes and decide how to plot the information and then work some things out to do with it. So again, when you choose your axes, on this one I probably have the time, the delivery time up the side and the peaches information along the bottom. Peaches is going to go up to 6, so that's quite easy. 1, 2, 3 to set up that axis. Delivery time is going to go up to a maximum of 18, so make sure you're careful with your axes. Maybe go up in 2, 4, 6 all the way up to 18, but be really careful when drawing that axis. The other part of this question is they want you to draw a line of best fit, but if you look on part C they ask you to work out the mean or the mean delivery time. So you have to work out the mean of these numbers. How do you work out the mean? That's right, you add them all up and then you divide by the number. So if we add all of those up, and we've got 10, 4, 14, 18 and 6, and divide by the number of times you've got. Well, there's 5 different times, so I'm going to divide by 5 and that will give me my mean. And that means we can then plot the mean point. We've got the mean of the bad peaches and the mean delivery time. That will give us a point on our scatter, and when we draw a line of best fit it must go through that point. Okay, I think you're ready to go, guys. Good luck.